Hi, I'm Amrit. I'm a developer advocate at Google, and today we're going to talk about performance tooling. Imagine you built an amazing app, and you've now rolled it out to a lot of users. They've installed your app, and then they tend to start seeing that even though you've built an amazing UI for it, some things are not right. Things are loading up slowly, there are crashes at times, or it takes too much of battery, for instance. These are all things that can hurt the user experience really, really badly for a user. They might not be able to kind of use the app and slowly start uninstalling, and you'll start seeing a bigger uninstall. If you look at performance, some of the things that we talked about, it's actually a two-step process. You have to be proactive about it, and at the same time, be reactive to changes also. What I mean by proactive here is that you've got to plan, measure, and profile your app before you even publish it. You might want to look at your competition. You want to look at how well your app is performing, and maybe benchmark against some of your competition to see whether your app is actually meeting the expectations of your user. And once you publish your app, that doesn't mean that your job ends there. You need to kind of continuously monitor and at the same debug any issues that are coming. So once you roll out your app to millions of devices and users are starting to use it, you need to take that data and start improving upon areas that you find that the app is lacking at. I'm going to talk about some of the tools that you can use and techniques that you can use to improve, measure, profile your app. I'll start with Android Profiler. We released this with Android Studio 3.0. I hope most of you guys are using that now. And this is a replacement for the Android Debug Monitor. This is the unified time model that you most probably work with when you're looking at performance. Let's take a look at all the different areas in it. You have the CPU, memory, and your network. Three things actually shown in terms of a timeline. And on top of it, you also have input events. This allows you to kind of track how your app is actually performing in these three respects with respect to what the user is doing. We also flag things like system events like rotation of the screen. Now, if you see, the icon shows that the screen is actually getting rotated at this point, the activity is getting recreated, and you see a small spike in the CPU at that point. So you can relate some of these things in that one timeline. Now, you also have the activity state here, which allows you to kind of see what your activity is doing at this point of time. Is the activity stopping? Is it actually running right now? Where is the CPU spike? Where is the memory spike coming in? And you can use all these points of information together as you see the timeline. Let me jump into the CPU profiler. You might want to understand, because we have, in India, if you look at it, we have a varied set of devices. We have a lot of low-powered devices, too, where the processor is not as fast as the latest and greatest of devices, and people still continue to use that. You want to be able to understand how your app is performing with respect to CPU. This is, when you click on the CPU part, the tab, this is what gets loaded up. Now, let me walk you through some of the sections here. You have the thread list, which is basically all the threads that were running in the timeline that you've talked about. You have the CPU activity, which basically has three things that you can very quickly look at. The green, which is basically how the CPU is used by your application. The lighter green, which shows how CPU is used by the system. So you can make a correlation of how you're contributing to the system's load. And also the number of threads that are running on the device. The dotted line represents the number of threads. So you can sometimes relate that, oh, there are more threads running right now, so my CPU is spiking. The system's not loaded, but my app is actually using a lot of the CPU, things like that. You also have a thread state. So when there's a CPU spike, you can see, oh, what all threads are actually running in the system right now. And you can look at that correlation and see, oh, this is where I might need to optimize the CPU. Maybe this thread, the code that runs in this thread is where I want to kind of make some changes so that the CPU spike is kind of reduced at that point of time. But if you want to go more deeper into it, you need to do something called method profiling. This is basically tracking the entry and exit of methods that your app uses. There are two ways in which you can actually do method tracing. One, I mean, the red button basically starts it off. But the more interesting thing is the drop-down next to it. The first method is that you can sample. You can do it in a sampled manner, which means the system will actually, what it will do is, it will take it at regular intervals of time, and it will start tracing, capturing all the invocations and exits of application functions. And the other one is called instrumented. Instrumented is where every single invocation is actually tracked. A lot of you might think, oh, then the instrumented is much better, right? Because we get a much more detailed information. Not exactly, because instrumented has a much more higher load on the system because it has to work continuously. So if you use sampled, the state is not loaded as much. So depending on the use case that you're using and what you're trying to solve here, take one of these two. Let me load up one of the profiles that you have. Even though I'm showing static images here, these are continuous timelines that you can actually take. So this is a timeline that got captured, and then I've loaded that data in here. If you would see at the bottom, you have the call chart that is there. And at the top, you have the timeline and the threads and their states. Let's go a little deeper. I'm selecting a certain section of the timeline where I see a CPU spike. And then we want to analyze that a little better here. Now, the selected recording is the area that is in the blue. And you have the call chart for that area displayed and visualized here. Let's go deeper into that. Now, when you look at the call chart, there are a couple of things that you want to very quickly understand. The orange basically represents all the function calls which are system-made. So your onCreate, what activity classes would do, things like that, fragments would do. And the system calls are all the orange ones. Your code is basically the green bars in there. And you can also see some blue color. That's basically system library code. So let me take one example here. If you look at that long green bar, which is basically an activity create, it is at a point where your system is rotating. You have the image detail activity getting loaded. And you see that the onCreate is really long. But when you go a little deeper into that, you see that the set content view in the activity is only 1/3 of the time. The rest of it is actually done by an initialization process called init, and then an image fetcher. Now, armed with this information, you can very quickly understand that, hey, in this case, my activity could have loaded a lot faster if I can move some of this code that is written by my application, is in my application, to another later point of time, or initialize it somewhere else. Your activity would load. So there's a point where the user could see a slow loading activity, and you have an option to kind of improve it by maybe rearranging your code or rearranging the flow of the data that you have in your application. So instances like this are very easy to pick up when you start analyzing this. This is not the only way you analyze. If you look at it, you can also see a top-down approach where you start from the top thread in your application, and you can see all the way down to the final invocation. This could be used when you want to trace a path and see all the functions that are being called and how they are getting what effect they have on the CPU. The other one is a bottom-up approach. Now that you've identified, hey, I have this function is a place where I'm going to optimize. How is this going to affect? Who are calling this one? So you take that function, and you can do a bottom-up approach. That is this particular screen that I'm talking about right now. And that helps. The second one we're going to talk about is memory. This, again, for us, is very critical. For India, we have the variety of devices, and the amount of RAM on these devices from low to high is such a big variance. You would see that out-of-memory exceptions is more common in some of the applications that we build and we deploy in our region here. So to help with that, you have the memory profiler, which basically looks at, it color codes all the different sections of your memory, the Java code, the native heap, the stack, all these things are color-coded differently so that you understand how they are growing at each point of time. You also have things like GC events being shown here, which lets you know that, hey, at this point of time, the garbage collector kicked in. You have the option to actually force GC to understand the behavior at certain points of time to see that at this point, when I'm doing a lot of computation and the memory is increasing, can I force a GC to do something? Will that affect the application? Now, let's take a segment of it and analyze it a little more deeply. Now, when you select a set time segment, what default comes in the default heap, as is shown below, with all the allocations that are there. This is per class. So each class or a type is actually shown, and how much of allocation and deallocation happened over that period of time is clearly shown here. You can also arrange it by call stack. This is how you would want to, once you've identified some areas that you want to look into, the arrange by call stack and other options that we here will help you really dig deeper into this. Now, when you arrange by call stack, you would see that, hey, at this function, my app is allocating these variables or this much memory. Now, you found out that at this function, the app is slowing down, or there's a lot of GC events happening. You want to identify why. So you drill down and see the allocation count, and you can fine-tune it to the last function call that has been made, and you can look at how much it is allocating. Now, there is another option that we have, which is very interesting, which is called which is basically by arranged by package. Now, in most of our apps, we have a lot of third-party libraries being added so that we reuse some of the code. Now, you might want to just work on certain parts of your code and optimize it to the best, leaving aside code that you don't have actually access for. You're actually just using the library in that case. So when you want to do that, one of the things you could do is you could select by package and avoid all the packages that you're not interested in focusing on, and then just select the ones that you want to work with, thereby improving those packages and the code that you've actually written. When you select one of the allocated allocations, what you will see is all the instances of that in that timeline that got allocated as well as deallocated with some additional parameters. So this gives you a fair sense of how many threads are getting constructed, how many times this is getting called. Should I actually make a static variable of this to improve? You can get to start thinking of all these options with that. Now, clicking on one of those instances, you also get the allocation stack. Like in every place, you want to kind of dig a lot deeper into it. So you can do a heap dump and then load that into the profiler. And this is how you will see a heap dump getting loaded. The same way you have the splits that I talked about. But when you click on the instance properties, you can also get the references to the instance. So if you see that you have a memory leak, this is a much faster way to kind of figure out how you want to drill down to the point and see what references are holding to this one. So it's much easier to work with them. The last profiler that I want to talk about today is the network profiler. Now, network, as we know, right now we have a lot of bandwidth, but people kind of tend to optimize a lot for network usage. And that is because one of the bigger concerns is the battery life of the device. Battery life can be affected drastically by overusing the network because the radio states, as most of you might know, when you use the network radio, it actually goes to this high power state. Then as you stop using it, it comes to this low power idle state, but it still consumes power. And then only it shuts down after some time. If you continuously use to transfer data or receive data, what happens is the device will keep the network hardware at its high power state, thereby consuming more battery. You don't want an experience where users love your app, but your app drains the battery so quickly that they decide to uninstall. So the network profiler will allow you to kind of see how much data you're transferring. At the same time, look at the radio states to understand whether you're actually impacting battery because of the network. So that blue line is where the network, different states of the radio is actually shown, where you've seen it at high power, or low power, or if the person is using Wi-Fi. Now, you have a data transfer graph also. You have something like how much data got transferred, how much data was received. So the blue line here, the blue graph indicates how much data transfer is happening at what speed. And the orange line, not the dotted one, the orange solid line is how much data is being received. The dotted line is the number of connections that you're actually having, the network connections you're keeping. Sometimes you see that you are keeping unnecessary network connections and keeping a lot of resources. So these graphs very quickly visualize areas of concern for you and allow you to kind of drill down deeper to fix the problem. Like all the other graphs, you can actually take a time slice of this, look deeper into it. When you take a time slice, every HTTPS and HTTP requests are shown, visualized with a timeline next to it. They will tell you what type of network call it is, what have you actually requested for in the taking the MIME, what is the size of that request, so that you can go in and how much time it took. So you can then literally go in and see, hey, I want to optimize this one network call. If you select one of those networks, you actually would get the response. If it's an image, that image will be actually rendered. This allows you to find things like, hey, is my cache working really right? Am I downloading the same image too many times? Am I downloading the right resolution for the image from the server? And you can also look at the headers to think about issues, find about issues, things like how much time to live is actually being shared by the server, so that the HTTP cache would hold this for longer. Things like that. You can also look at the call stack and see additional parameters here. Now with Oreo, Android Oreo, you can profile any debuggable app without any changes to it. But if you're actually targeting Nougat or below, you would actually have to enable advanced profiling and build it on Android Studio 3.0. Again, in order to enable this, if you're running the app, the system will actually prompt you with a nice dialog. So you just have to say OK, and it'll be the advanced profiling will be automatically enabled for you. The second one I want to talk about is API debugging. Now, once you have a problem, you want to go back and look at a little more into what's happening, right? Now, to profile and debug, you might be like developing a game using a completely different thing other than Android Studio. And you want an option to kind of go ahead and analyze and profile your app using Android Studio. In this case, we have added a new section where you can actually build your APK. When your APK is ready, then use Android Studio to go ahead and profile and find all the information that we talked about earlier here. So when you do that, what happens is it creates a dummy project, loads your APK, and then opens it up by default in the APK analyzer. The APK, and you can then go ahead and attach your sources, go ahead and attach your libraries, so that dependencies and other things can be fulfilled, and you can start profiling your code better. With the APK Analyzer, that's the next tool that I want to talk about. How many of you guys use APK Analyzer? I'm glad, a lot of you. Those who haven't raised your hands, please go back and look at that tool. It's really useful stuff. So you can actually invoke the APK Analyzer from the build menu, or every time you create a build, it will actually show up with this nice dialog where it says, locate your APK or analyze the APK. Clicking on analyze will actually load up a screen like this, where your app is actually shown with its different parameters in the APK, the different sections, things like classes, the dex files, the resources, your manifest, how much space they're taking with respect to total size of your application. By the way, there are two sizes being displayed here. One is a raw size, which is the APK size as a file. And the second one is a download size. The download size is basically how much data is going to be downloaded for this app when you are actually installing it from Play Store. Because Play Store can do some additional compression on that. So sometimes these numbers cannot match with each other, won't match with each other. Play Store most probably will have a better will compress it a lot smaller and send it down the line. So the user will only download the download size, whereas your APK size is the size on the disk. And looking at this, like in this case, we have loaded the dex file. You can see that the classes.dex is taking the most amount of space in your APK. We have visualized it by showing you the size, the percentage of size this file is actually taking in your APK. A lot of times, it's not the classes.dex, but your resources that you will see as the offender when it comes to the APK size increase. You might have a resource which is really large, and that's occupying a lot of space. Then this allows you to kind of drill down to the area in your app which is taking most space and reduce the APK size drastically. And I want to also call out that this can be run from command line now. So you can actually add it to your CI systems and make this as an output, which is going to your CI. Every time your CI build runs, automated run, you can actually run this and get the data and do comparisons. Write a little bit of code, shell script. You can get comparisons against your previous one. Or you can get more data about what has increased, where's the area that this build needs to focus a little more with respect to app size. The last section that I want to call out is Android Vitals, which is actually part of the Play Store. Here, what we have done is we have actually visualized a few of the parameters that are in the real world. So your app is out there. It's being installed and used by a lot of users. And if you look at these users, how is this app behaving on their devices? Now, that data is collected and actually given to you in the Play console. And as a developer, when you sign into the Play console, you can go into the Android Vitals page, and you would see things like ANR rate, crash rate in real world. We visualize some of these parameters. ANR, application not responding. Your crash rates, how many crashes are happening in the real world. Slow rendering. This is something that's not easy to kind of find out otherwise. On how many percentage of devices is slow rendering happening? Frozen frames. Maybe it's because GC comes into picture at times. But this is really good information for you to start saying, hey, I have this one problem in the real world. Let me start going back and being reactive about things. Let me go profile again, find out the areas that are of trouble, and then fix this, because this must be the thing that is affecting my users a lot. There are more things like stuck wake locks. You might not recognize. There might be coding errors or things that you missed out of your testing which have stuck wake locks, which is again going to ensure, which is going to make sure that the CPU doesn't shut down or the screen doesn't shut down, and at the end, increase the battery usage of your app. Or excessive wake-ups. Is your app in the real world waking up too many times because of external signals, push notifications, or just because there are too many alarms on it? Any of these things, background processes, all these things waking up your app too many times. And we also have a section in DAC, developer.android.com, where we have specified for each section how the Android Vitals, what are they, and how you might want to respond and work with them. That's it from me for today. I hope some of these things are useful for you, and you've learned something new here. Go back and profile your apps, and if you make substantial improvements, do let us know your story so that we can come in and help you with more stuff. Thank you.